Welcome to i4 Institute. My name is Khushbu. I am working as software developer in i4 Technolabs Private Limited. In this series, we are going to talk about SQL and cover up all the basics related to SQL and database. We are going to cover up all these points. So have a look on this. Let's start with definition of SQL. What is SQL? So SQL stands for Structured Query Language. It is non-procedural language which allows us to communicate with database wherever you can visualize, whether you can visualize or manipulate the data. This is confirmed by a standard American National Standard Institute, short form is ANSI. Now, wherever there is a SQL, there is going to be a database. So what is database? A database is nothing but an organized collection of a data which is typically stored in an electronic format. Database allows you to input, manage, organize and retrieve the data quickly as per our need. Traditional databases which are organized by record, that is rows, fields, that is columns, and stored in a table which are stored in database files. It supports storage and manipulation of data both. It makes the easy data management. Now you know that data stored in database is in format of tables which has columns and rows. So a database table is nothing but a collection of rows and columns that is used to organize information about a single topic. Each row within a table corresponds to a single record and contains several attributes that describes the row. These tables are stored in databases. You can see here we have an example of a typical database table. It has 4 columns, that is employee ID, last name, first name and department, and 3 records, or you can say rows, which are stored in a table. Now we know that what is database, what is tables, columns and rows. In order to understand how we use these tables, columns and rows, we have to know about SQL statements. So in SQL there are 4 types of statement. Number 1, data definition language. In short, we call them DDL. Number 2, data manipulation language, that is DML. Number 3, data control language, DCL. And finally number 4, that is transaction control language, TCL. Let's see them in detail. Data definition language. These statements are used to alter, modify a database or table structure and schema. This statement handles the design and storage of database objects. It includes the following: create statement, that is a create new table, database or schema. Alter statement, that is alter existing table or alter existing column or alter existing column description, whatever you want to alter. Drop, that is delete existing object from a database. Now DML, data manipulation language. These statement affects records in a table. These are basic operations we perform on data, such as selecting a few records from a table, inserting a new record, deleting unnecessary records, and updating, modifying existing records. It includes the following: select, that is select records from a table. Insert, that is insert new records into the table. Update or modify existing records which are already stored in the table. Delete, that is delete existing records in the table. Now data control language. Data control language statements are used mostly by database administrator who can limit access to certain database objects for each user. It is done for the security. These statement controls are the level of access that user have on database object. It includes the following, that is grant, allow user to read and write on certain database object. Revoke, keeps the user from read-write permission on database objects. Last one is transaction control language. These statements are used when we work on more than one object at a time, and TCL is responsible that either all the commands have run successfully or none of them run at all. These statement allows you to control and manage transaction to maintain the integrity of a data with SQL statements. Begin transactions, open a transaction. Commit transaction, that commits a transaction. rollback a transaction in case of any error occur during a whole transaction. Let me show you one of the GDL and DML statement. You can see here I created a table named employee, create table employee, having column that is employee ID, integer that is a type of a column, integer, not null, primary key. I will explain this afterwards. Second one is last name, having a data type varchar 50. It means that it allows of 50 characters in the column, not more than that. Third one is first name with same data type varchar 50. Third one is department, that is character of 10. Its length should be a 10 only. Date of birth, data type must be a date. It will not take any text value. Last one is the employee code. Same, it having a character that is of a 6. I have given this null and unique. I will explain it to you later. Another one is DML statement. I already created a table employee. Now I want to insert a record in an employee table. From the following, you can see here I have written a statement that is insert into table name, which is the employee, bracket open, and number of the name of the columns which I want to insert. I have given employee ID, last name, first name, department, date of birth, employee code, and values. Please remember the sequence of this row and values you are inserting must be a same. So here 100 refers to a employee ID, Smith refers to a last name, Bob refers to a first name, IT refers to a department, 05/28/1985 that is refers to a date of birth, and employee 001 refers to a employee code. Let's run this script so you have a better view. I am running this create table employee part. Execute. You can say command completed successfully. It means employee table is successfully created. Now I am just doing is inserting records in table employee. I am running this script as well. You can see here it is written 4 rows affected. It means I have inserted 4 rows in employee table. Let us see how employee table looks. I am writing a select query here. You can see select star from employee. Let me execute it. You can see here it has a 4 rows with all the columns and its respective value. Now suppose I want to alter table employee and want to add new column in table employee. So how I will do it? Let me show you. You can see here I have added a DDL statement stating alter table employee. Add is active, that is my name of the column. Bit value, type is a bit. It means it will have a 0 or 1 bit value only. By default, I want 1 to be stored in each row which are already existed. Not null. It means this column should be always a not null. Not null means nullable values are not allowed. So I have given a default one. Let me run this statement. Now let's check select star from employee. You can see here new column is added, is active, and default value is 1 to all the rows. Now similarly, if I want to update a row, then there is another DML statement, update employee. Suppose I want to set is active equal to 0 for employee ID 100. So what I have to do is update employee set is active, that is the name of a column and its value equal to 0, where employee ID equal to 100 means it will only update a single row which have employee ID equal to 100. Let me run this statement as well. One row affected, it means one row is updated. Let me run select star from employee. You can see here employee ID having 100 row, employee ID having employee ID equal to 100, having a column is active equal to 0 is updated. Similarly, if suppose I want to delete a column date of birth from employee table, which suppose I want to delete a column date of birth from employee table. I don't want date of birth in my employee table anymore. So there is a simple GDL statement. Alter table employee, drop column date of birth. Let me run this. You can see here commands completed successfully. Now let me show you select query for this. You can see here the change. Date of birth column is deleted from the table, so that no more existence of a column date of birth. Now suppose I want to delete a single row from employee where employee ID is 103. So what I have to do is write a DML statement stating delete from employee where employee ID equal to 103. Let me run this. Now select star from employee. You can see here there is only a 3 rows. The employee ID with 103 is not here. So 103 is deleted from the table employee. These are some of the examples of DML and DTL statements. Some of the SQL data definition commands: create schema, create table, creates a new table in users database schema, not null ensures the column will not have any null values, unique, no duplicate values, but unique key always allow a single null value. Primary key defines a primary key of a table, always unique, but it will not allow a null value. Foreign key defines a foreign key for a table. It means two tables are linked with a single key. We can say that table 1 have a foreign key of table 2, like that. Default value for a column when no value is given. Check, that is constraint used to validate data in an attribute. Create index, to creating a indexes for a table. Create view, create dynamic or subset of a rows or columns from one or more tables. It behaves similarly like a table, but it is a virtual table. You can say it as view is like a virtual table. Alter table, for modifications of a table structure, to add column, to modify a column, or to delete a column, or to change data type or whatever you want to do using a alter statement, it can be possible. Create table, to create a new table. Drop table permanently deletes the table. Drop index permanently deletes the index. Drop view permanently deletes a view. Data manipulation commands are insert, select, where, group by, having, order by, update, delete, commit, rollback. The descriptions are as follow. You can see here. Now we have operators. Operators can be seen in almost every programming languages. In SQL, this also exists. An operator is a character used in SQL statement. They are used to specify conditions and actions which they perform. We have different types of operators in SQL. which are comparison operations, logical operation, arithmetic operation, special operation, aggregate functions like count, minimum, maximum, sum and average. Let me create an example for us to better understand it. Suppose I want first name and last name as a single column from employee table. So what is my select statement? It is like select last name plus first name as full name from employee. You can see here Smith Bob, John Susan and Adams John are selected from this table employee as a full name. So suppose I want a space in between full name, first name and last name. So I have just appended space between two columns. Now suppose I want to select record from employee where employee ID is 100 or 101. So what will be my query? Employee where employee ID equal to 100 or employee ID equal to 101. Let me run this. You can see at the bottom only two rows having ID equal to 100 or ID equal to 101 are selected. These are some of the examples for operators. Let's move to next point, data types. It defines what kind of value a column can contain. I already explained you while creating a table employee. There are like integer, varchar, character. These all are types of data. Pay close attention to expected use of attributes for sorting and data retrieval purpose. Main data types are numeric. In that, number, integer, small integer, decimal. Character, that is character L, varchar L or varchar 2, that is L. Date for datetime format. Constraints are part of a schema definition which ensures few rules which must be followed during a schema generation. Here we have not null constraint, check constraints and default constraints. Not null indicates that column cannot store a null value. Check ensures that value in a column meets a specific condition. Default, that is, specifies a default value when specified none for this column. As you can see here, while creating a table, I given not null to employee ID. It means employee ID never be null whenever new rows are inserted or updated. You can here see while alter statement, I added a new column is active, type bit, default 1 not null. It means that it will never store a not null value, and by default if not mention what to insert in this column, then by default it will store 1. This is the difference between default value and not null together. Now we have keys. Keys are used for defining the behavior or relation of tables. We have unique key, primary key, foreign key, composite key and candidate key. So what is unique key? Unique key ensures that each row for a column must have a unique value. What is primary key? Then primary key is a combination of not null and unique value. Ensures that a column have a unique identity identity which helps to find a particular record in a table, that is more easily and quickly. Each table can have one primary key. Foreign key ensures the referential integrity of the data in one table to match values in another table. A foreign key in one table points to a primary key in another table. What is composite key? Composite key is nothing but a combination of two or more columns in a table that can be used to uniquely identify each row in the table. When the columns are combined, uniqueness is guaranteed. But when it taken individually, it does not guarantee uniqueness. So, when you want a uniqueness, composite key is used. Candidate key. It is a candidate for primary key of a table. In simple words, we can understand that such type of keys which fulfill all the requirements of primary key, which is not null and have unique record, is a candidate for a primary key. Let me show you an example. Here you can see employee ID integer not null primary key. It means in this employee ID is never be nullable and no two rows have a same employee ID. This is a main concept of primary key. Here you can see employee code is unique. It means it can be a nullable but unique. So no two rows have a same employee code, but it can have one nullable value. This is the basic difference between a primary key and unique key. Next are SQL indexes. There are two types of indexes, clustered indexed and non-clustered. So what are clustered? Cluster indexes are sort and store the data rows in a table or a view based on their key values. These the columns included in index definition. There can be only one cluster index per table because the data rows themselves can be sorted in only one order. Non-cluster indexes have a structure separate from the data rows. A non-cluster index contains a non-cluster index key values, and each key value entry has a pointer to the data row that contains the key value. And finally, we have functions. SQL has many built-in functions for performing calculation on data. SQL Aggregate Functions, SQL Scalar Functions, SQL Aggregate Functions. It returns a single value calculated from values in a column. Useful aggregate functions are average returns the average value, count returns the number of rows, first returns the first value, last returns the last value, max returns the largest value, mean returns the smallest value, sum returns the sum. Now SQL Scalar Functions. It returns a single value based on the input value. Useful scalar functions are UCase that converts a field to uppercase, LCase converts a field to lowercase, mid extract character from a text field, len returns the length of a text field, round rounds a numeric field to a number of decimals specified. Now returns the current system date and time. Format formats how a field is to be displayed. These are for the references. Hopefully you have enjoyed this session. Thank you for watching.